carved in stone, with standards set by hands of old. The tale of systems vast was told, yet in those roots a war did rise. The Unix clans with rival cries, from battles born a path was clear, where freedom's call we'd soon revere. From Unix roof through wars we came, to Linux lands where all lay claim. With T2's light our journey's course, we forge the future source by...
Welcome everyone, my name is René Rewe. I do T2 Linux for 25 years, and since 5 years we fix all bugs everyone else leaves behind for all Linux packages, glibc, and keeping all the necessities for high-performance, scalable RISC systems alive. Case in point, of course, SPARC, if not SGI and stuff. But for some years, I wondered that we build T2, we release T2, we test stuff, and we have some bugs. And thanks to your subscription, your Patreon, amazing things, more and more people support me there, and we can finally fix the last bugs that are in glibc for 4 years. And they manifested, for example, in SPARC, in all SPARC systems, the Sun, now Oracle, scalable processor architecture, that if you run stuff like time, so this bug manifested, so basically the system wasn't stable and randomly failing, just how you want your system to be. Your superior GNU, Free Software Foundation, Linux Foundation, kernel Linux. And so the two major things that I noticed, like it's randomly failing, right? The two major things I noticed, if you stopped something and you continue, you would get error waiting for child process, interrupted system call. And that happened to me, I mean, beside other general instability and stuff, that happened to me basically each time I used that, like you do with developer things. And the second thing is, if you shut down the system, it wouldn't shut down. It would hang and not shut down. Certainly, so like you would power off or whatnot, right? And so the last days, so this bug, this is basically the quick summary of this bug, other free software and GNU Linaro of other company bugs live in there. And I find it mind-blowing that sure, SPARC is not the most popular architecture, but hey, new glibc versions, mask in Gen 2 because it's stable, and Debian, SPARC is not really stable anymore. Maybe someone will fix it for us. So 4 years later, we did. Thanks for all your super thanks, Patreon, and buying me coffee and stuff. Because this stuff, we live streamed it live the last days. We live streamed even 10 hours of this. So how did I tackle that, right? Naturally, so I knew somehow shut down things, so I started. So one thing is I looked here into S-trace and compared this. So like, so simple thing, sleep, time something, some other process, sleep in this example, doesn't matter. Like usually internally, so this also happened for T2, our Linux distribution. You installed some package, you press Ctrl-Z to stop a process, you continue it, and it would fail. So if we Ctrl-Z that, we foreground, and then we get interrupted system call, right? So we started guru meditating, like what is happening. So wait, wait, excuse me, wasn't the most healthy the last week. So wait fails, where is it even? So restart system call, here's the last thing somewhere, here's also, yeah, here, clone, wait for. So here's wait for, so that's using wait for internal system call of user space calling into the Linux kernel of, hey, wait for some processes. That's correctly restarting some interrupted system call, and that gets interrupted system call. So far, so good. All behavior, we compared this with other non-failing systems like x86 where that worked and where this would not fail with interrupt system call. In parallel, we started to run, because we're not using systemd, we support that theoretically in T2 Linux, but not primarily. So in parallel, we also looked into RCD. So basically, we guru meditated over the stuff, like what could possibly go wrong there, that nobody else found in 4 years. Must be rocket science. init system. So we also looked here, and we found out that of all things, so this kill all would the kill all here of killing all the remaining processes would cause exactly the same of waiting. And so because this kill all then fails with interrupted system call, it actually exits out of the shellcode here and doesn't continue the last thing. So basically the first kill all failed with interrupted system call, killing the first process, and waiting there, and then all the rest there didn't execute. Right? So this could be anything, right? It could be GCC miscompile, it could be kernel bug, but we tested old kernel and it happens the same on old kernels and so on. So we started to guru meditate this, we debugged this, and we came to the conclusion that officers like this took hours, right? Like you basically need to do detective work and look into each bit, like everything, like every S-trace. The problem is we tried even to attach a debugger. The problem is due to the signal handling, signals being involved here, we couldn't easily debug that. It's also a shock to me that with a free software foundation GNU debugger, GCC, GNU compiler collection, GNU debugger, and GNU Glibc, this is not somehow more integrated that this would work mostly, but basically we debugged through there. It was difficult. It didn't even always load the matching modules and allowed us to set breakpoints where we wanted. But anyway, so we guru meditated step through that stuff, and then eventually we started, because it was basically most likely not a kernel bug. We came to the conclusion, okay, most likely, because also we then, given we have a 25-year history of running T2 Linux for all CPU architectures, we extracted an old CD, because I was like, I'm pretty sure this worked 5 years ago, right? I do this for 25 years. I did run 20 years ago. My secondary workstation was a 64-bit Ultra SPARC system that worked rock solid stable, right? Like Linux and GNU, 20 years ago was rock solid stable and stuff, hardware isolated, and the best in 64 before even AMD and Intel at 64. But now it's randomly failing, right? So we started to bisect the glibc, or like what you do, which obviously was also quite some endeavor and took some time. So bisecting this, we came to this here from Linaro.org, but whoever, doesn't matter. I'm not shaming here individual people, but so that is like, this is the first thing that broke. Like with this SPARC, use Linux KBI for syscall return. So that is the first git bisect of like building glibc versions. Like, yeah, okay, from here on it fails. In 2020, January 28th, 2020, this changes the SPARC internal syscall macro. It's like, sounds like it could be something, right? To return a negative value instead of the G1 register, value in the error macro argument. Syscall string macro is also changed to not set the G1 register. SPARC having massive registers, 128 or whatnot, and with 32 generally addressable, like not the x86, like when SPARC was invented, like 1987 or whatnot. This was highest performance and rocket science, right? Not like the 6.5 general purpose registers of x86, 386 goodness back in the day. So we have here like 32 freaking registers, and we can like use input, output, 8 registers, function arguments input, 8 registers, function argument output, general, temporary registers, high performance, scalable, brisk living, right? So this is G1, in case you're wondering. Since 01, the output 1 register there already holds all the required information. We only talk about a system call, like some int, open, read, write, system call, internally system call, trapping into the kernel, and that return value. Like in return int, we talk about one integer return value, right? Which is usually negative or -1 for failure, or negative error number. So macro syscall is no longer required, and the eternal syscall error p macro follows. So the C excuse me, the C people, like C++ evil, God forbid Rust, but like, yeah, macro, like C++, like meta programming with preprocessor macros, amazing stuff. So checked on, like also, what do they even write here? Recurring failed, redefinitions also no longer required. Checked on SPARC, it fixes, so it fixes allegedly. So I for 20 has never had an issue, but they say it fixes allegedly sporadic issues on SPARC 32, maybe any SPARC, or SPARC 32 by clock nanosleep does not act as a cancellation entry point. So also test case, by the way, right? Like hearsay, is it a mission to break glibc so that they can delete it now? Because like, hey, it was broken for 4 years, nobody cared. Like, hey, if you don't give me test case, like examples and like what the heck, because like it was working perfectly, and after that it doesn't. So I don't know what nano sleep cancellation that fixes, but it breaks everything else. Amazing. So surprisingly, we guru meditated over this patch forever. Hours. Relatively simple. Here's the Syscall macro, except like there are also some other patches on top, which is also, and thanks for the super chat, why we cannot simply revert this. So due to cleanups, they change your stuff, they actually clean it up. That's amazing, thanks for that. But because they, after this, with more patches, clean up more, we could not, with later versions the last 4 years, simply revert it because all the cleaned up infrastructure wasn't there anymore. So they just fixed some C, like preprocessor macro, like glorified portable assembler preprocessor stuff here around. So what is difficult is that it changes here all the subtle arrow stuff. So what this is GCC assembler templates of telling instead of having this hard-coded Intel assembler like on Microsoft Visual C, it basically allows the compiler of like, it allows a programmer to create templates, like this text templates here, which also come from here. Here's the defined, I was like, is GNU programmers and Linux open source ecosystem generating assembler from macro preprocessors. Like that's a define, that's a string, they put it in here, they add stuff, it's like, yeah, they took some guru meditation, right? Like if this confuses you, it confused me also for hours. So basically they also, what makes this harder to read is because they changed inline Syscall to internal Syscall and stuff, like everything, like you need to like follow the spaghetti stuff here. It's like, why does it fail now? Like, why does it break? They also changed, so the main change is that here, built-in expect, so they what they previously did, this details I also didn't know. Like people always like, why does this German Übercoder knows all the things? Because I'm the last person, the last old school person to fix this kind of breakage that other people leave in there for 4 years that nobody else wanted to fix, has no knowledge to fix, has no time to fix, because hey, even me, it took me 20 hours thanks to your share, like, and subscribes. The main thing, so what I also didn't know, the SPARC, so all the architectures have different calling conventions, and for SPARC, the calling convention is, as you see at the end, so adding all the the arguments here in output registers, because they do this because they are, excuse me, maybe a little bit code or whatnot. So everything in the O output registers, and the G1 is the name. This name is misleading. It took me so long to guru meditate because some things are misleading. I would not have named them like that. Naming stuff difficult. 2024 or 2020 naming stuff difficult. Name I find misleading. I would have named the Syscall because that is the Syscall number. So it's like 1, 2, 3, 4, 574, whatnot. So I would have Syscall number, but name, okay, whatever. So they added this. So this code was here, like this C function or this is inline. This is used from C code and like do some Syscall here, like open file, read, write and stuff, right? So there they instantiate this, like, hey, C++ in C. They instantiate this code by using this macro, simply concatenating this text here together. So here's a Syscall name. So that's what they changed, right? They clean this a little bit up. I mean, I find it a little bit fishy because this argument like this fixes some nanosleep cancellation point. Nah, I don't really quite see it, but whatever. Also, in the future, can we agree that code is not committed without either like test case example, because like I can't even verify it. Like what? Like, hey, give me freaking example, right? Because like I can't even double check that your nano sleep cancellation point, whatever. And so obviously anything of this fine-grained stuff could be cursedly broken in some way, right? Like that's why we guru meditate for hours. And so yeah, that are the changes. These changes are not so large, and like this changes, I just document this here that you learned something, and the broader audience who always is surprised that people like me keep the open source ecosystem working and together. What it takes, right? Even so, it could be a 1 line, but this is even a like 86 line. Not that much changes, and it took 20 hours, most of which live on Twitch, there in the Twitch links, of guru meditating that on SPARC hardware, right? And even analyzing, here's a kernel. Excuse me, it is what it is, right? I'm already better. Thank you for your wishes. The Syscall return is in the Linux kernel Arch SPARC 64, like Control Z, like stopping this, Arch SPARC kernel signal 64, and here's the SIG return somewhere. Do RT SIG return of. Wait, is it even? Is it even the right file? No, it is not. Sorry. It's in Syscall. How dare I mislead you? It's in Syscall. Return Syscall here. Return from fork. Return Syscall. Here's a Syscall return and find SPARC assembly. And so obviously we guru meditated here. What went wrong? We compared that here with strace. It's like, why is it failing? And so on, right? To no avail. We was like, dude, it's like, it looks like it should work. Like, why does it not work? Like, dude, that is hilarious. I even then, this morning, like I fixed this literally today. That is how hot this code is. And as a pro tip, so because there's also one more thing, which, so to the fairness, some people chimed in there because one detail of the system call, which they didn't mention here, is that this is here is branch on carry, like similar to x86, like all the 386 and x8064 lovers. So here's a system call. TA is trap all. Oh wait, this is even the wrong. Yeah, no. So TA this is a 32-bit SPARC. This here is 64-bit SPARC. So this is TA trap always. 6D for 64-bit system call, and here TA 10 hex for the 32-bit, good old-fashioned 32-bit code. So all the arguments are set up into the 0, 2, or 0 and so on registers. Then TA trap always. This A stands, this is integer conditional code, so you could also trap like not equal and stuff, right? Like our RISC architecture is not much more amazing than this, but anyway. So what changed here is the kernel additionally, just on SPARC, and maybe some other architectures. So on SPARC, the kernel sets the carry flag if the system call failed. And this is actually pretty stupid. I would have never done that like this. So by the way, this is a historic inconvenience and performance, decreasing performance. I don't know why they have done it like that. I would say no sane programmer would do it like that. Probably Sun has done it in Sun OS slow Laris because it's so slow. And maybe the Linux kernel SPARC programmers 25 years ago were like, yeah, let's copy Sun OS because standards or whatnot. Because what is super silly here is, normally I would, and this Linaro developer, for glibc, would use the negative value as like, hey, we have the error code as a negative value, right? Like just test negative, like just have the number. Positive stuff is fine and negative stuff is error. But no, the Linux kernel people here in Syscall return here compare the output compare output register 0 to -e restart block, which is the first non-user space should not be visible error. Excuse me. And here they again branch equal or whatnot here for carry flag. Branch equal or whatnot. Branch compare 1 forward, which is there. So there is the error code. I just need to summarize this now. I would do it when I'm more healthy, but excuse me. Now my memory is fresh and I need to move on with the next things. So here's check if for successful Syscall return. So here is not error, right? Like so, and what they do here is in the error path, this is sub, they subtract, so for most RISC architectures, G0, you probably know from university, many RISC architectures, including RISC-V, have the global 0 register always being 0, so they subtract the output thing here from 0. This is a little bit stupidly written. I think so. There is a synthetic instruction. I have no idea why the SPARC people would not have written. I believe it should be like that, negate, maybe that. In also that you learn something for modern, like RISC-V also has many synthetic instructions, meaning they reuse other forms, like because obviously negate, like you in RISC you don't implement negate as a dedicated complex instruction, but like, hey, that's the same as subtracting the value from 0 from the global 0 register. So Syscall failure set carry condition code also get ups error. So this is actually wasting performance, because why is this wasting performance? We negate it here, return to user, and in glibc we negate it again. Like we literally, like the SPARC developers, hey, we have optimized Linux kernel system called so much more than slow lerers, and like, yeah, they so carefully optimized, they waste 2 instructions for no good reason. Anyway, because the problem is, so yeah, so not only 2 instructions, and the new code does not fully take, so the new code only uses a carry flag to invert, to negate this again, to negate, like, because actually that's not absolute, because it's already absolute, so yeah, negate. And actually, as discussed, like to their credit, Florian Weimar also, like, this change consistent, yada yada. Also, in fact, Syscall already said, this is answer. So to their credit, it was a little bit discussed, but it still was applied, because to Florian Weimar's credit, he also pointed out, this is also why it took me extra guru meditation, that somewhere they mentioned, Florian mentioned 4 years ago that where is that? So this was not the only thing, right? There was somewhere that he discussed that this changes some range of return values. This is also why it took me an extra hour or 2 guru meditation, because the Linux kernel, as you see here, checks for restart block, right? And that is not the last error code. So actually this leaves, as you see here, restart block is here 516. So this leaves all of those potentially should not happen, because as Linus Torvalds wrote here, this should never be seen by user program. To return one of restart code signal pending must be set. Note that ptrace can observe these at syscall exit tracing, as seen here, right there, of restart this somewhere, here, restart this here, if I would not have some mouse copy and paste, hello, here. So as rightfully pointed out, restart this, right? And this is why I guru meditated 3, 4, or 5 hours, because this change is also like, this is, in my opinion, this should never have been committed like this. Because it was even discussed here somewhere that it leaves. But yeah, here I double checked this against the kernel sources, and entry S. So entry S is a 32-bit. We looked at this 64-bit code passes. That is, Florian rightfully points that out. It is just slightly different written in the older 32-bit code pass in entry S. The 64-bit code pass is in syscall S. Return syscall here, load, compare here, restart, so comparing the same restart block, load, there's whatnot, set, so this is setting the processor status register carry flag in G2, and then fast forward, jump there for taking the absolute value. So, but is not 4095, which they changed here, right? Somewhere in the patch. So also glibc. So the problem is that, I mean, first of all, this is really fishy, right? Like I would say this should not have been done like this. It's absolutely silly because it's a little bit a kernel bug that always was there, like basically probably for like 25 years. That the Linux kernel sets the conditional flag on SPARC and SPARC 64. There is theoretically an restart error that user space should usually not see except strace for process tracing. But like if the value is minus 516 or 520, this code here compares that it is not greater or equal than that, negative 2 complement some billion whatnot, right? F minus 516, 514. And so the Linux kernel actually returns a negative value, right? For everything between 516 minus 516 and 4000 minus 4096, right? This is a little bit like this is a little bit nah. I mean, not only they waste 2 instructions for taking the absolute value and negating it again. Also, they leave there some range of error messages. So the return value is positive, except if it's between minus 516 and minus 4096 or any other return value. Anyway, so I guru meditated, I single stepped. Oh, manual. Thanks for all the Patreon and super thanks for healthcare and staying healthy. Because obviously, who else will fix that for you in the future? So this is the code for wait for. That is diffed. So we guru meditated everything, right? I literally said yesterday in a nearly 7-hour live stream on Twitch, we need to understand each line. And yesterday I didn't understand every line. I did SPARC assembly, I did basically any assembler between ARM and x86, but like this was 15 years ago, right? Like 20 years ago. And I need to relearn, right? Like after 20 years, like, yeah, I've seen that, but I even fixed a bug in the Linux floating point emulator and other stuff for SPARC 25 years ago. But like, it's like, why does it, like, it looks, I mean, beside, there are some fishy things and double negate and the Syscall range. Like basically, I spent hours Google meditating. What happens here between this minus is like, is this, because we see here E restart, right? Like this, you cannot believe I usually sit here, we fix it, right? Yesterday I was sitting here, like, what the freaking heck is even going on here, right? Like we can't even like, we were sitting here with GDB and like, why does GDB like literally, do we have GDB in, do we have, probably not, but we can load that. I'm not sure if, I might have this currently as user bin time. Like basically here, maybe break, was it wait 3 or so, run this with sleep whatnot, layout ASM, right? Like this is how we literally single step through here and it's like, what's going on? Where's even our system call? Like why does GDB not show this nice alert to us? Like so much room to improvement. It's like where are we even? Like where is it? Where's our, because the code is also here in like, for example, wait, do we still have that here in Glibc here? The code is also like wait 3 is branch calling to wait 4, and here we have if that define, like basically even as in glibc proper, so often like this if then this thing assume wait ID, it's like what is even set, what is even compiled here. Then we have here Syscall like return, Syscall cancel, like what's that even doing, right? Like and then either like this, like return if def and our like this or here Z or -1 is like where are we, what is built, like what's going on, where's our system call, and why does it not work, and like even when we finally, there must be somewhere, I think we have not even been, so the C code is like that is still glibc's C code. And here is, wait, move of 5. It's basically also pointless, kind of. Actually, we could actually continue and stop it here, and this also stopped wrongly. Are we process exited normally? Okay, we couldn't. Anyway, believe me, it was not. It was as uneasy as it. So you will not believe. Only today, like, how did we fix this? Like, basically, we tried to single step through the stuff in the assembly as good as we could, and it's like it looked okay. It's like, why does it not work? I mean, the code is fishy, and it's like it was discussed. Basically, there's also somewhere here. Like I said, it's like Florian, shout out there, thanks for this review, highly valuable. A pity that it was committed like this, because it was exactly that was discussed here. Sorry for my coughing here. It is what it is when you held this. Like I said, looks like also like I'm not sure what with this no, I think this analysis is not correct, because they speculate here, like Florian speculates, like looks like someone forgot to update this code. I don't think so. I think this code is kinder what it should be, just like this should not leak. It's like this are not valid user space error codes, and they should not leak into user space. So I don't think it was forgotten to be updated. The only thing is fishy here is if this should not leak, maybe it should be returned as 0 and not as minus 516. But it is what it is, right? And it's fishy that any Linux SPARC kernel ever leaked this as not error in conditional flags, but in contrast to all the other positive numbers, a negative number, or so that's hey, you could detect it, right? Like usually it should return a positive number. So if it returns a negative number between 4096 and 516, it's one of those, which shouldn't happen. So yeah. Anyway, a little bit strange here, and that is what I analyzed. Like, I basically focused on, like, okay, that's right. I analyzed for hours what could happen there between the kernel, like how does this break something, what's going on. I tried to work on it, fix it, like it didn't fix anything. And so today we started from this code here, because like here in git show, so this code, I finally figured, like 20 hours in, I started to only take some things, because my thinking was, okay, I don't think it's error code. Like my intuition was there is something else going on there. I thought like some sick action handler stuff, because what's all right, I can for this the signal restarts here, strace says so. If you strace this is here here of to be restarted if SA, somewhere it says this, if SA restart is set, and so the program sets here run real-time signals, RT, real-time also signals sick action for it, because you can control this, how the signals are handled. Should they be ignored? Do you want to handle this and stuff? So there's like handler, ignore, interrupted and quit, and here for SA flags you can control whether you want system calls, like in progress system calls, like a long read, write, or await, other such system calls, whether you want the kernel to restart them. And so this was set here, and I was actually starting to debug in the kernel what's going on, like how can it happen, like basically can this changes, subtle changes in 6 system call return values, can this break this SA auto restart, signal auto restart handling here. And only when, and then I thought like maybe something in the glibc, but I thought it's handled in the kernel, and the code is here in signal restart. So here is do RT sig return, and always pending restarts somewhere of here, syscall restart in the kernel, and this for each architecture. Here it is restarted, and I was like, how can this break? I don't see how it breaks. There must be somewhere where there must be some other subtle change, that this change of assembler sequence, I was like, dude, someone must have probably hard-coded some value of if you restart the system call and the system calls have now another size here, that this doesn't work anymore. And you was it right? Like this was like this kind of like, this is my intuition. Like there is something way more complex going on than just single stepping through the stuff. And that's also why I would regularly call, do not commit stuff fully tested without test suite and without test case and stuff. Because this simple, hey, let's clean up some stuff, that broke all of SPARC Signal. Since 4 years, any system call restart handling is entirely broken, as seen here, right? And the way that is broken, I found out, and I can pinpoint it out now entirely. The result of all this guru meditation is, when I changed this, because I then started to do half of this change, like when does it really break? Because I thought it's here, because this is removing here one instruction of not, because previously they stored a global error of like, they basically stored the carry flag here in G1. And so this became one instruction shorter of not storing it anymore, because we have already then a negative value, a renegated value. Performance is crying in the grave. May it rest in peace. And it's like, something of that must be going on there, right? Like I didn't find it in glibc, of course, and stuff. And then, when I diffed it here, so that is the diff between a working system call and a broken system call. So basically between old and new, this is SPARC assembly, fixed lengths, non-complex, non-variable lengths. Is that all the beauty? Like big endian, readable numbers, fixed lengths. So not much stuff changes here. Like how does it break? Like I went through here this morning live on Twitch. Okay, save, set high, call here of SPARC get PC thunk and stuff. Like hey, it's all the same. Like do what even like and the only major or manual. I'm so sorry for getting here some COVID. The major change is like wait a second. The major, like even all the, like moving all the input arguments to output arguments, which are, it's also a little bit silly to be honest, but whatever. Maybe they move that here. The only argument would argue this is completely stupid. The only argument I could like reusing that so that if you have values that you need to continue to use, you could still continue to use your input arguments and only the output arguments are clobbered, but nah, otherwise, nah, whatever. Because it's a little bit, it's basically wasting here some CPU cycles of instructions of copying the stuff over or moving the stuff over, whatever. As you see, this code changed, loading the system call number that I believe it probably should be wait 4 or something. System call 7, whatever that is, maybe wait 4. It's loading that earlier. Now, previously, the storing of the system call number was done last, before the trap all 60 for the system call into the Linux kernel. And boy, that is the issue. That is the bug. That is like, hey, we clean up some stuff, we fix some stuff, and it's like, you even see that here. But the thing is, because I didn't know that this is an issue, like, so even the developer didn't know that it's an issue. Like, nobody who reviewed this, like, it's broken since then, just because this instruction is not before the system call. Because what's happening here is, and this is also not documented, right? I even Googled, like, because this developer, it's like, yeah, it's now using the KABI. I Googled KABI, obviously KABI for Linux kernel ABI. I didn't even find, like, there is not even, if you Google Linux SPARC KABI, there is, like, if you even Google Linux KABI, there find it. Like, sure, there are, like, some other Linux kernel, but, like, you Google that, you find this thread. It's like, yay. You Google that for SPARC, you find, like, nothing except old Sun documentation, right? So what's happening here is, like, that is never recurrently. Please, I mean, thanks for the cleanup. You broke SPARC for 4 years, and if I would not have done it probably for another 4 years, because who's using... Don't delay. Try the last Linux distribution that supports SPARC and MIPS and PA-RISC and ARM and RISC-V. The way this breaks, and I guru meditated, I should like just, we have 32, we have 32 general purpose out of a register window of 128, I believe, registers. this surely like, so you look over that, right? Like it's just like, it's like the order doesn't matter. It's like, it's all independent. G1, immediate, I, O, 0, 1, 2, 3. It's like, it's obviously not in any way, shape or form order dependent, right? But what's happening here is, here, in the syscall, in the Linux kernel, in the syscall restart for SPARC, here, no highlight, e restart, no interrupt, I believe. This oh wait, this one? Yeah, I think this one. Here, they restore the original I/O, which I'm not even sure, maybe that's a bug, because this original I/O is whatever. Apparently this original I/O is, maybe that's a bug, but it always was buggy. I'm running old kernels because, spoiler alert, we are bisecting another SPARC bug because there are more. Bugs always come in a dozen, right? Because who else will fix them? And we rewind, look at that. PC, program counter. We rewind that. This is probably that PC and next PC, I believe, probably, plus minus give or take. And look at that. So the original PC is probably, the original PC's restart this stuff here of, that's probably interrupted with, wherever that was between all the, here SAE restart this. Because that is what, so that's what's happening, right? So that's the Linux kernel is somehow internally calling this. If it's a bug, maybe. I don't want to change the Linux kernel because the problem is, if I change on the Linux kernel, I don't know if David S. Miller or other SPARC geniuses invented it like that. I mean, plus the other negated calling convention, absolute and negated calling convention. Yeah, a little bit, yeah. But like, I don't want to break more, right? I always work on assumption the people knew what they're doing. The Linux kernel always was like this. And if we change it now, like if we would change the Linux kernel for whatever reason of not restoring here or original I/O for you restart this, because that's what we are seeing, right? It's failing with E restart, here E interrupted system call. And so we rewind, and so what happens is, we are here at trap always. We rewind previously, and previously this reloaded the system call number. And now in the new code, it's moving I3 into O3. So that is why I confirmed this, I changed this. So the change for that, funded by your views here, your Patreon, you go buy me coffee, your Twitch, your GitHub sponsorship and all the other good stuff. Recurrently fixing the open source Linux ecosystem. The fix for that is as simple, and that applies to all glibcs for the last 4 years and fixes this. We tested this. The fix is as simple as moving this code. Actually, I can show you that here. The fix is simple, and this is like, how did they test this? Like, everyone's person Debian Gen 2 and T2 system is unstable. I have no idea. That is why don't trust people with checked on SPARC 64 GNU. Like how? How? Because like, sure, some hello world printed hello Lord, but like, your system does not survive a boot and shut down. I also don't know what customers do they have. They allegedly fixed some, I've never seen clock nanosleep doesn't cancellation entry point. No idea what they mean by that. Hey, test case. Is that a mission of Free Software Foundation? Let's break each architecture, and if people don't fix it in 4 years, we will delete it. So Unix can applaud the deletion. I don't understand this. Maybe this is just coincidence, it's just strange, but maybe we can agree of never change a running system, don't change what you don't fully understand, what you have not test suited, and include some reproducible test suite, because I have no idea what clock nanosleep he fixed. Sure, the code is a little bit cleaner, it also doesn't work anymore. I mean, I'm only the messenger, don't shoot the messenger. It's like I only fixed it for you here, live on Twitch. yeah, the fix is, I probably sent it sooner than later to the free software GNU people. The fix is just moving all those G1s here at the end of loading this right in SPARC sysdep page, right, like you would expect. So, and we are running this. Say hello to a fully working Sun latest and last. I mean, fully working. We have some more bugs to fix. There is some other instability that is in the kernel. But otherwise, the only Linux distribution live here on this channel that supports all CPU architectures and has them fixed working, and Xorg server running on AMD GPU, because AMD Radeon, maybe. And if that would not be all, working freaking audio on, will you believe, pipe, wire, ignore that, pipe, wire pulls, wire plumber. Right, I think maybe this doesn't set the output volume because reasons, for the high definition mono speaker built into the high-end RISC Unix workstations. And yes, I can start an X server and have fancy colored X terms, if not. Share, like, and subscribe, because we have a random... There is also another bug in the kernel beside all this fishiness here. Yeah, I would not have done it like this. It's not German Meister, not quality engineering. But I love David S. Miller anyway. Probably Sano has inherited. I see you, I hear you. And yeah, of course, similar cleanups are in the Linux kernel. You see, recurring theme, right? We cleaned up some stuff. It's cleaner now, but yeah, now it's also the kernel is newer kernel. There's a reason why I'm currently bisect. We're in the middle of also bisecting 5.9 something commit-ish dirty, because spoiler, I mean, yeah, it works, but I mean, this kernel currently is more stable, but latest kernels rarely boot, because 4 years of clean code Linux Foundation cleanups give you random memory corruption in SPARC 64. But fear not. Share, like, and subscribe. Patreon, GitHub, Twitch, and YouTube. Super thanks and stuff. And don't delay, try T2 Linux today, because we will fix that soon. We have working hardware-sled graphic on the only Linux distribution that has working AMD GPU and Radeon on SPARC 64 and Hewlett-Packard HPP ARISC, and audio and non-randomly failing binaries and audio and what else, and X and Wayland, and the future is now. And let's celebrate together. Have a good time. Download this on any system. Report bugs. Send patches. Send blankets, flowers. Money is always good. And I guess nothing like enjoying. Last but not least, basically that's it. All your contributions, all your views go to upstreaming monumental fixes of, I have no idea what others doing, but that's clearly way too broken to use. So keep that in mind. I appreciate anything. Love you all the users, all the reporters, and let's probably take a quick look at the comments of all the quickly, because otherwise don't forget to keep the comments brief, and don't forget some super things and subscriptions. What do I want to say? All right, that otherwise if this live stream is too long, people don't like it and don't watch it. So let's also, of course, we are live streaming from superior high performance T2. People always ask, what operating system do I run? Of course, I only run my own operating system. I don't have time for other people's bugs and marginalities. And we live stream from this, we build on this, and we run our RISC workstations from this. Oops, also wrong focus. I wanted to focus here to take a look at the comments. 5x5 on audio and video. Hey there, welcome everyone. Got download glibc see from all because whatnot. Rather donate. Would you rather I donate through YouTube or Patreon? YouTube takes more commission. Patreon and I think Patreon. So the best is PayPal Direct, then Patreon, GitHub. The video content platforms, Google, Amazon, Twitch, take 25, 30, whatnot % per permission. So if not directly PayPal, then Patreon is the next best, which is still relatively low, barely higher than PayPal, I believe. Maybe a little bit, like a % or 2 or maybe 3 or whatnot, but not like 20 to 30% like YouTube. Which VM do you use? I basically don't care. I've used Blackbox on necessities for glorious workstation living for decades. The last years, even my first live streams were on Blackbox. T2 ships with XFCE for easy of use and attracting new users. And do we ship with Sway? I think we do. I used Sway the last years, recently switched for Hyperland. Not 100% happy because some Hyperland bugs, but it looks a little bit better. So basically I would use Sway, but I use Hyperland for more animation effects of the future of Linux desktop is now. Are you using QWERTY? Usually yes, except in BIOS and whatnot. I might try, I understand the reasoning of like programmer-friendly, non-alphanumerical special character braces layout. I might try that because I would want to try some keyboards that are only available in US layout, so maybe I try to some US layout. But yeah, also for my business stuff, I usually type some German umlauts and umlauts asset and stuff. And I'm historically more used, but I understand the reasoning and I will probably try that soon. So share, like, subscribe if you want to see me suffer, especially on probably live on Twitch suffering. Using also, actually I tested that with a Sun type whatnot keyboard. Absolutely cursed, can't recommend. I actually got this cheap. This is a Unix layout keyboard, US Unix, absolutely cursed. I got this actually for like, hey, so it's like US layout, right? And obviously for stop A here on this Ultra SPARC Open Firmware stuff. But super cursed that control is freaking there, caps lock is freaking there, and like, is that the only thing? Is there also... Alright, escape, like all the most important keys, escape, like, I will make a video, like, thankfully I only paid $6, euros. I got this just some month ago, thankfully cheap. First I thought like, hey, Unix freaking layout, I never had a Unix freaking layout. And then I got it, it's like, dude, like, how could they put escape there? How could they put control there? Could they put caps lock there? It's like, absolutely, sure, you can get used to every shit, but like, what were the Sun people smoking who freaking did this keyboard? I don't know. I so wanted to love this keyboard, but thanks to that, I only use it for the stop key for Sun firmware stopping. Yeah, let's celebrate the first super on live stream. That's amazing. The more the better, and highly appreciate this, because as people, for decades, people didn't want to believe me that stuff is recurrently so broken, and that it takes also my customers, right, embedded customers, I estimate that it probably takes 8 hours and it takes 16 hours. This is why, right? You think, oh yeah, I will probably figure out. You like, when I was young and naive, like this kind of stuff, like we did embedded x86, embedded PowerPC and stuff, like I was like, you think we got it? It's like, yeah, probably 4 hours. We doubled that 8 hours. And customers like, 8 hours? Like, yeah, some safety margin. And then it's like, customer, hello, it took like freaking 16 hours. How can it take 16 hours? Like, have you seen the PowerPC assembly? It's like, have you seen what broken stuff there people from somewhere did? Like, it's like, and it's like, I don't want to pay you 16 hours. Like, yeah, okay, fine, and pay me 8 hours and the rest 8 hours. Like, how do open source developers stay poor? Because like, they're constantly underpaid for having to deal with such cursed bullshit. And then customers like, it's open source, it has to work, or it's open source, I can't pay you so much. It's like, yeah, thanks there to those previous customers. Why did I turn to Twitch and YouTube? Because I'm sick and tired of like, this took 16 hours. It's like, dude, 16 hours was fast. Have you seen all the other people who have not fixed this in 4 years? That's the reason nobody fixed this in 4 years, because it took me 20 hours to fix. So yeah. Therefore it's long int. Yeah, long int is also, this is also, this clean code here is not amazing. I discussed this in the Twitch live stream. I actually said this, I pointed this out, like I would have only done long and log in. They basically, also this here, this Lenaro person, I would already not employ them for like, if you work for me and you give me code like this, like, yeah, dude, either you do it better next time or we have no future, because like there is long is enough, like long int is superfluous, like long int is still, long is long int, and like the more long int, and there is long, like why do you put int there? It's like, yeah, long is long enough. Int doesn't make it shorter and long doesn't make it longer. But the knob is a branch. Yes, that's a delay slot. And also, what I only realized the other day, I didn't know that there was like this space here is superfluous. But apparently, some programmers, some RISC programmers, at least GNU or so, I don't know if leave in the comments below if it's a widespread industry standard. Apparently, they usually leave a space here for delay slots. So usually, all the space things here, like one extra space, usually indicate delay slot. You can't rely on that. Some common sense required. But in this GNU and Linux kernel, did they had that here? Excuse me. Of course, the assembler will assemble it anyway. Yeah, there it was. Which probably were the same developers, Yannick Jelnik and David S. Miller. Amazing people, love you all, appreciate this good stuff. All the SPARC code, thanks for writing this all standing on shoulders of giants. Yet, and that's the sad thing, standing on the shoulders of giants, David S. Miller, Jakub Jelnik, and all the other who SunOS only like, okay. And all the other who wrote that, do we have here an, is it entry as, right? I feel like, yeah, David S. Miller, I don't know personally, but yeah, all right, actually Miguel de Casa, of all the people, Jakub Jelinek, just as I said, the other I didn't have personally contact with, but apparently also contributed to something. These are for me the big names, but I might be late, I might be biased. But thanks to all of you, you rock. Thanks for reverse engineering, porting, and all this good stuff. The system call thing is a little bit cursed. Yeah, maybe SunOS inspired, but it is what it is. I appreciate all of this, but for me it's like this stuff was working, and then people, it's like let's clean stuff up for. Also, like this, they didn't even explain. Like maybe don't trust people who do not explain how this fixes clock nanosleep cancellation entry point, because like I don't even know what precisely he means with that. He didn't provide a test case, so something. It's just broken enough that it's Syscall, like Syscall interrupted system call. What is it called? Reply stuff is broken. So it's like, what was it? Also, the thing is up like like. Have you seen a SPARC system recently uptime 6 hours or days because people debug meditated all the bugs out of it? Interrupted system call restart. Restart, of course. Also, if you're new to this stuff, in any case, even if you say, yeah, but SPARC and whatnot, like, hey, did you know that you can control the system call restart stuff here and ignoring stuff in RT-SIG action for signals? Handlers, ignore and restart and stuff. That's a generic thing for all your x86, Sysc, ARM, MIPS, and any RISC-V and Friends architecture. Clean up code and broke stuff. Like literally remember that upstream any, yes, IDT WinChip of like so much stuff fixed. Like, hey, probably I should make a list, which, by the way, I highly appreciate. We have 2 new corporate sponsors because I think it might be related of constantly fixing really time-consuming stuff for the IT industry that nobody else dares looking into. Apparently, maybe. But fact is, we have a $50 new. If you're wondering how how a couple of amazing sponsors add up here, we have a $50 shout out to a $50 corporate sponsor on GitHub and a $50 corporate sponsor on Patreon. I don't know if they want to be publicly named except what is visible there, but I highly appreciate this, and that is of course what motivates me to why do we keep fixing this stuff, because nobody else does, and otherwise my precious collection of SPARC machines doesn't work. And I probably should make here a $512 a month minimum goal. And maybe I should actually raise commercial T2 user and backer and stuff from $10. Probably still keep selling myself too cheap here. I probably should make only $512 a month, which we are still far away of. Surprisingly, of hey, $188 a month. To free a patch a month. Because have you seen how time-consuming all this stuff is? So, some last, where are we? Some last words. Guy, word, gospel, Linux, gods, inline assembly, syntax is so cursed. Yeah, I agree, not the super greatest fan. I love the expandability, but yeah, the syntax is a little bit nah. But I got used to it. Like, when I was young and naive, I was like, it doesn't look like turbo assembler. And I was like, yeah. And the only thing is that Intel syntax has, besides Intel syntax, Intel assembler syntax looks different. It also has source and destination reversed, right? So that is always, it's a bit of a pity that like early on and decades ago, AT&T and Intel and Borland and stuff couldn't agree. Because like having like 40 years later, having to deal with different even source and, not even RISC and CISC and everyone names their stuff slightly different, but even source and destination, sure, you get used to everything, but like even I sometimes, on a first glance, gets this confused, especially if I didn't look to assembly for someday. And the new members, it is amazing. This guy is very good, thank you. The comments are gold, and if you're new to the stuff, we regularly do this and have otherwise viral videos and constantly bug fixing of writing a USB driver from scratch in 3 hours and fixing all kinds of other cursed stuff with our most viral video. Hopefully later this year reaching 2 million. We are on a good path, currently 1.2 nearly. And if you want to see if you're sad and need something to watch or whatnot, we have thousands of videos in the archive from the last years. Yeah, probably something FPGA, MT32, electronic repairs, you name it. MIDI on an FPGA, RISC-V on an FPGA, VGA, DRAM controller on FPGA. And oh, by the way, Piotr Eston's 1-bit squares, friends and family, white quark. Markan42 Glasgow Interface Explorer finally arrived the other day, so buckle up for more FPGA interface exploring, reverse engineering, and Python controlled electronic engineering and programming and stuff for shout out of yes, AI, so much to autofocus there. That just arrived the other day, and we will soon have fun, more FPGA fun, totally open source, logic analyzer, protocol analyzer, amazing stuff. Crowdfunding, maybe you can still order. I said this the other day, I'm totally not affiliated, and it's open source and open hardware, totally not affiliated. Logic analyzer, EEPROM programming, SPI, I2C, your possibilities are endless. I have a suspicion maybe eventually the price might increase due to component shortages and other things. So red text is invisible. Which red text? That one, what none? Anyway, we are there. We discussed that. That is just a summary. And if you want to see all of that, it's still in the if you want to see me in real life, that is on Twitch, where we because YouTube is running relatively well by itself with more popular summaries. You can watch this, you can follow on for free on Twitch, and with a subscription watch this replays for some weeks. And that was bisecting that 6 hours 50 minutes. If you want to rewatch that in detail and like a thriller, like a Sherlock Holmes in IT novel, and I hope I copied this correct, right? If you want to rewatch all the stuff. The reason I additionally turned to Twitch is because I use YouTube now for the more mainstream summaries, because all the some videos are running well enough. Excuse me. And if I live stream too much random stuff in between, my YouTube runs less successful. That is why all the live development we do on Twitch these days, and post the summaries and more mainstream work in between Twitch and YouTube. So, me too, white space, perfect, red, not really sure which red text you mean. Bounty, Raspberry Pi bug report 2. What do you mean bounty for that? Anyway, I have already 666 lines of to do, so, and T2. If you didn't know that, we are one of those who actually really give back, so all your share, likes and subscribes, Patreon, and buying me coffee. Buy me coffee in case you like that more for some reason. I only post this for like, have you seen how much work all of this is? That we give back. We are one of the few, like, search for another Linux distribution who, like Debian, Gentoo, SUSE, Fedora, Red Hat, IBM, Oracle. If you go to our GitHub with T2, we have feature bounties, not bug bounties, because like, hey, other people do the bugs, I can't pay you for other people's bugs. But we have feature bounties of stuff I would want to see implemented, including, hey, SPARC 64 Sun for the primary LDOM control, even XL bounty. And the more successful you make us with all your likes and stuff, the more we can increase them. We already increased them, we will increase them further. They are more even easy if you're saying, like, obviously that is a big thing, that yes is versus more. Hey, share, like, subscribe, and we raise those labels. Here of issues, we also have small things for, like, you are just getting started, and like, they just package some small things and get 20 bucks, which other Linux distribution does that, right? That's basically it for today. Again, welcome to all of you. What's your daily keyword? My daily keyword is currently, like, previously it was a Sun Type 5 with a 30 speed adapter, currently Philco Magic Touch 2, which I unboxed here also with Cherry MX Brown. Maybe Cherry, maybe in the, I know in the Cherry is not the highest regarded anymore. Maybe I should try some other. Also, I would probably not recommend, in the meantime, I would probably something, I also tried Silent Red in another keyboard. I would probably migrate to a little slightly different silent clicky linear whatnot alternative thing. I will probably try some, but yeah, Jeff Gilling highly appreciates this. Yes, that's why LOL, that is amazing. I appreciate this very much, and I'm really thankful for everyone who recognizes all the 50,000, I believe, hours I put into that over the last 20 years on Basic C. That is amazing. I hope you enjoyed this and learned something. Reference what red text was told to, what you told to ignore. Told to ignore. Is there a reference about red text? Which red text was it? This, I think this you meant, right, somewhere I had red text, right, I had somewhere, right, where was it even? I even totally forgot which one this was. Somewhere. This was pipe R. This was starting. Yeah, this is just not all. That's not the full. Also, we have share, like, and subscribe, Patreon, all the good stuff, because we have Firefox to fix for all this big Endian architectures. Absolutely mind blowing for me that I keep Firefox building and stuff, and even had it working on PowerPC 5 years ago and on SPARC 64 3 years ago, and now it's entirely broken again. So we are getting there. P3, hey, we also unbroke P3, right? They also introduced a new bug there, live on Twitch and only seen on T2 Linux. And we have P3 RSX to do eventually someday, and we have Firefox to refix for all those architectures because somehow all of Big Endian is broken. So obviously we want a freaking brother on our necessities for greatest risk reduced instruction set living. Big Endian, no less living. Where can we hear the T2 Linux song? I will post that. Basically we can that's the video. We fixed things. It took a while. New ISO soon, new amazingly improved T2 releases. Yes, we still have further stability things, so probably T2, new T2 ISOs after we fixed, we found and fixed stability issue. If we are unlucky, the bisecting might reveal that the stability issue here is cursed and difficult as that. So if there is some cleanup, whatnot assembly, it's like, it might even be not easy to fix in case, because there are some really cursed SPARC cleanups, as you would expect over 4 years of, hey, we cleaned up some stuff, we didn't quite test it and boot it and stuff, but hey, the code looks cleaner. So, and also we wanted to remove some other stuff here and there. So due to SPARC was the last user and we cleaned this up now, it's a little bit broken now. They excuse me, often remove other code, and then we can't remove it because like this other infrastructure, like, hey, the last user SPARC is gone, so let's clean this up even more, and then we can't revert it easily. So it is entirely possible that whatever we find there even takes similar amounts of 20 hours of guru meditation if we soon find that and stuff. So that's it. The outro, I post the link. That's on whatever AI music site. If you share, like, and subscribe enough, my goal is to eventually re-record this. I can play some guitar and little keyboard and drums and stuff. So the more you share, subscribe, the more non-AI real song produced there will be. That's it for today. I hope you enjoyed and learned something. And don't delay and try T2 Linux for free today. And where is that? We have some. So the link to that AI site has a couple of songs. So I hope you leave us in the comments which you enjoy the most.
In the world of T2, where the source is king, build a custom Linux, let the freedom ring. From on to Android basics, risk find insight, optimize for power all day and night. Flash-based freedom, tailor-made for you. T2 SDE, low-code packages. Cross-component magic, modular design. Automated builds, make your system shine. Control your versions, choose what you need. Latest patches, blazing speed. Embedded systems, lightweight and lean. A custom distro, like you've never seen. Source-based freedom, tailor-made for you. T2 SDE, local packages. Cross-compiling magic, modular design. Automated builds, make your system shine. Control your versions, choose what you need. Latest patches, blazing speed. Embedded systems, lightweight and lean. A custom distro, like you've never seen. Source-based freedom, tailor-made for you. T2 SDE, local packages. Cross-compiling magic, modular design. Automated builds, make your system shine. system shine.